Right now, as you settle in, there are photons of light entering your window that left their star before you were born. Some of that light has been traveling for decades, some of it for centuries, and some of it, the faintest glimmers you might see on a dark night, began their journey before any human civilization existed. You don't have to do anything with that thought. You don't have to remember it or take notes. It's just something that's true, something happening quietly above you while you rest. Tonight, we're going to spend some time with the stars, not in any hurried way, not with any particular destination in mind. Just gently, the way you might sit with an old friend who doesn't need you to say anything at all. The stars are patient. They've been burning for billions of years, and they'll keep burning long after this night is over. There's no rush here, nothing urgent, just you and the quiet, and some thoughts about light and time, and the surprising ways we're connected to things very far away. So let your shoulders drop a little, let your breathing find its own rhythm, and whenever you feel like closing your eyes, you can. The stars will still be there, they always are. Here's something simple to start with. A star is just a ball of gas. That's really all it is, mostly hydrogen with some helium mixed in. These are the lightest, simplest elements in the universe, and somehow, when you gather enough of them together in one place, they begin to glow. The reason they glow has to do with pressure. When you have an enormous amount of gas, and we're talking about amounts so large that your mind can't really picture them, gravity pulls all that material inward. The gas at the center gets squeezed, and when gas gets squeezed, it heats up. You've maybe noticed this in small ways. If you've ever pumped up a bicycle tire and felt the pump get warm, that's the same basic idea. Compression creates heat. Now imagine compression on a scale where the temperature at the center reaches 15 million degrees. At that temperature, something remarkable happens. The hydrogen atoms start fusing together. They combine to form helium, and when they do, they release energy, light, heat, the stuff that makes a star shine. That's all a star is doing. It's converting hydrogen into helium and releasing energy in the process. It sounds simple when you say it like that, and in a way, it is simple, but it's also the reason anything exists at all. The star closest to us is the sun. It's so close that its light reaches us in just about 8 minutes. That might seem fast, but consider this. The sun is 93 million miles away. Light travels at about 186,000 miles every single second, and even at that speed, it still takes 8 minutes to cross the distance between the sun and the Earth. So when you see sunlight streaming through a window, you're seeing light that left the sun's surface 8 minutes ago. You're not seeing the sun as it is right now. You're seeing it as it was a little while in the past. This is true for everything in space. The farther away something is, the older the light is by the time it reaches you. For most things in your daily life, this doesn't matter. The lamp across the room is so close that its light reaches you almost instantly. But the stars are different. The stars are so far away that their light has been traveling for years before you see it. The nearest star beyond the sun is called Proxima Centauri. It's about 4 light years away. That means the light you see from it tonight left that star 4 years ago. Whatever was happening in your life 4 years ago, that's when this light began its journey toward your eyes. And Proxima Centauri is the closest one. There's a star called Sirius that you might have seen without knowing its name. It's the brightest star in the night sky, and it's been noticed by humans for as long as humans have looked up. The ancient Egyptians watched it carefully. So did the Greeks and the Romans and countless other cultures across thousands of years. Sirius is about 8.5 light years away. So when you look at it, you're seeing light that's been traveling for nearly a decade. The star you're looking at is the star as it was 8 years ago. Think about that for a moment. 8 years of travel. 8 years of that light moving through the emptiness of space, crossing distances so vast that they're hard to even imagine. And now, tonight, some of those photons are landing on the back of your eye. You're the end of a very long journey for that light. But Sirius is still relatively close. There are stars much farther away, stars whose light has been traveling for hundreds of years. There's a star called Betelgeuse which sits in the constellation Orion. You might recognize it as the reddish star in Orion's shoulder. It's one of the largest stars visible in our sky, a kind of star called a red supergiant. Betelgeuse is about 430 light-years away. The light you see from it tonight left that star around the year 1595. Shakespeare was alive then. Galileo hadn't yet pointed a telescope at the sky. The world was a very different place when that light began its journey. And yet here it is, arriving now, soft and reddish, finding its way to wherever you happen to be. There's a cluster of stars called the Pleiades, sometimes called the Seven Sisters. On a dark night, you can see them without a telescope, a small, hazy grouping of bluish stars. They're beautiful, and humans have been telling stories about them for thousands of years. Nearly every ancient culture had a name for them and myths to explain them. The Pleiades are about 440 light-years away. The light reaching us from those stars left them around the same time that European explorers were first sailing to the Americas. The light has been traveling ever since, through wars and plagues and revolutions, through the rise and fall of empires, through everything that has ever happened in the last 4 centuries, and now it's here, quietly visible if you know where to look. The light doesn't know any of that, of course. It's just light. It doesn't carry meaning or memory. But there's something calming about the idea that the sky is full of these long journeys, these quiet arrivals. Let's go farther. The Orion Nebula is a place where new stars are being born. It's a cloud of gas and dust, faintly visible to the naked eye as a hazy patch in Orion's sword. Astronomers have studied it carefully because it's one of the closest stellar nurseries to Earth. It's about 1,500 light-years away. That means the light you see from the Orion Nebula left there around the year 500 AD. The Roman Empire had recently fallen. The Middle Ages were just beginning in Europe. In Asia, the Tang dynasty was still 2 centuries away from its golden age. All of that history has unfolded in the time it took for that light to reach us. And the nebula itself has been slowly forming stars the whole time, patiently, in no particular hurry. When we look at the night sky, we're looking at many different times all at once. The stars are not all the same distance away, so the light from each one has been traveling for a different amount of time. Some of what we see is recent, relatively speaking. Some of it is ancient. In a sense, the sky is a kind of museum, but instead of displaying objects, it displays moments. Each star is a snapshot of itself from some time in the past, and the farther away it is, the older that snapshot. This means that some of the stars we see tonight may not even exist anymore. They might have burned out or exploded centuries ago. We wouldn't know because the light from that event hasn't reached us yet. We're still seeing the star as it was, shining peacefully, even if the star itself is already gone. This isn't sad, exactly. It's just the way things are when distances get very large. Everything we see is a little bit in the past. The stars just make that truth more obvious. You can close your eyes now if you like. You don't need to see anything for this part. Just listen and let your mind drift. Imagine all that light traveling through the dark. Not in straight lines exactly, because space itself is curved in places, but close enough to straight. Light doesn't get tired. It doesn't slow down unless something stops it. It just keeps going, year after year, century after century, until it lands on something. Some of it lands on planets. Some of it lands on moons. Some of it just keeps going forever into the deep emptiness between galaxies where it may never touch anything at all. And some of it lands here, on this small, blue planet with its thin shell of air, where a few billion humans live their lives mostly unaware of the light raining down from all directions, all the time. It's a quiet kind of abundance, a generosity that nobody planned. Let's talk about the sun again for a moment. It's easy to take the sun for granted because it's always there, rising and setting, warming the earth. But the sun is a star, the same as any of the others, just much closer. The sun is about 4.5 billion years old. It formed from a cloud of gas and dust, the same way all stars form. Gravity pulled the material together. The center got hot. Fusion began. And for the last 4.5 billion years, The sun has been steadily converting hydrogen into helium, releasing energy, keeping the planets warm. It's about halfway through its life. In another 5 billion years or so, it will start to run out of hydrogen in its core. When that happens, things will change. The sun will expand and become what's called a red giant, swelling outward until it's much larger than it is now. But that's a very long time from now. 5 billion years is an almost incomprehensible span of time. The entire history of life on Earth, from the first single-celled organisms to this present moment, has taken less than 4 billion years. So the sun has plenty of fuel left. It's in no hurry. Tonight, it's resting on the other side of the Earth, out of sight, but still there, still burning, still patient. The sun is what astronomers call a yellow dwarf. That's a category based on its size and temperature. It's not the biggest kind of star, and it's not the smallest. It's somewhere in the middle, which makes it fairly ordinary. But ordinary can be good. Ordinary stars tend to be stable. They don't flare too wildly or burn out too quickly. They just shine steadily for billions of years. The sun has been steady enough for life to develop on at least one of its planets. It's kept the Earth warm enough for liquid water, and water turns out to be very important for the kind of life we know about. Without the sun's constancy, none of this would be here. Not the oceans, not the forests, not you or me. So the sun is ordinary, but ordinary in a way that made everything possible. The most common kind of star in the universe is even smaller and dimmer than the sun. These stars are called red dwarfs. They make up about 3/4 of all the stars in the Milky Way, but you've probably never seen one because they're too faint to see with the naked eye. Red dwarfs are small. The smallest ones have only about 8% of the sun's mass. They're cool, as stars go, with surface temperatures around 3,000 degrees. They glow with a dim, reddish light, like embers in a fire. And they live for a very, very long time. This is one of the most calming facts about stars, I think. The smaller a star is, the longer it lasts. Big stars burn hot and fast. They use up their fuel in a few million years and then explode or collapse. But small stars are patient. They sip their fuel slowly, converting hydrogen into helium at a leisurely pace, and they can keep doing this for an almost unimaginable amount of time. A red dwarf with about 10% of the sun's mass could burn for 10 trillion years. Let that number settle for a moment. 10 trillion years. The universe itself is only about 14 billion years old. That means no red dwarf has ever died of old age. Not one. They've all been burning since they formed, and they'll keep burning for trillions of years more. When the universe is 100 times older than it is now, when all the massive stars have long since burned out, when the galaxies have drifted apart and the sky has grown darker, the red dwarfs will still be there, glowing faintly, taking their time. They'll be the last stars in the universe, the last lights in a very old cosmos. There's something reassuring about that, I think. The idea that some things are built to last, that not everything burns bright and fast, that patience, in the cosmic sense, is a kind of strength. The red dwarfs don't need attention. They don't dominate the night sky. Most people have never thought about them at all, but they're out there in enormous numbers, quietly doing what stars do. They'll outlast everything else. Let your thoughts slow down a little now. There's no hurry. The stars aren't going anywhere. Take a breath, let it out. Feel the weight of your body settling into wherever you're resting. The universe is very old and very large, and right now, in this moment, you don't need to do anything about that. You don't need to understand it or fix it or worry about it. You can just rest and let the facts be facts and let the stars keep burning without your help. Here's another thing that might be soothing to think about. You are, in a very real sense, made of the same stuff as the stars. This isn't poetry or metaphor, it's chemistry. The atoms in your body, the calcium in your bones, the iron in your blood, the carbon in your muscles and your DNA, these atoms were made inside stars. Not the sun, necessarily, but older stars, stars that lived and died billions of years ago. When those ancient stars ran out of fuel and exploded, they scattered their atoms across space. Those atoms drifted through clouds of gas and dust. Eventually, some of them came together to form new stars and planets and moons. And some of them, after a very long journey through a lot of different forms, became part of you. Let's slow down and look at this a little more carefully. In the beginning, right after the Big Bang, the universe contained only the simplest elements: hydrogen, helium, and a tiny bit of lithium. That was it. No carbon, no oxygen, no iron, just the lightest, simplest building blocks. The heavier elements didn't exist yet. They had to be made, and the only places hot enough to make them were the cores of stars. When a star like the Sun fuses hydrogen into helium, that's the first step. But bigger stars, with more pressure in their cores, can go further. They can fuse helium into carbon, carbon into oxygen, oxygen into heavier elements still. This process is called stellar nucleosynthesis, which is a complicated name for something simple. Stars are factories. They take light elements and forge them into heavier ones. In the very largest stars, this process continues until the core is full of iron. Iron is a kind of end point. Fusing iron doesn't release energy, it absorbs energy. So when a massive star builds up an iron core, it's reached the end of what fusion can do for it. At that point, the star collapses, the core implodes, and then, in a fraction of a second, the star rebounds in a colossal explosion called a supernova. During that explosion, there's so much energy flying around that even heavier elements get created. Gold, silver, uranium, all the elements heavier than iron are forged in the violence of a dying star. And then all of those elements, light and heavy, get flung outward into space. They travel for millions of years through the emptiness. They mix with clouds of gas. They become part of new stars, new planets, new solar systems. The Earth formed about 4.5 billion years ago from a cloud of gas and dust that was already rich in heavy elements. Those elements had come from earlier stars, stars that had lived and died before our solar system even existed. So the ground you walk on, the water you drink, the air you breathe, all of it contains atoms that were once inside a star. The iron at the center of every hemoglobin molecule in your blood, the molecule that carries oxygen through your body, that iron was forged in a stellar core billions of years ago. You carry a little piece of the stars inside you, literally, chemically. It's not a spiritual idea or a hopeful one, it's just what happened. Carl Sagan, the astronomer, liked to say that we are made of star stuff, and he was right. Nearly every atom in your body, except for the hydrogen, was made inside a star. The hydrogen has an even older story. It was made in the Big Bang itself, 14 billion years ago, in the first few minutes after the universe began. So some of what you're made of is even older than the stars. You're carrying around atoms that have been on a very long journey. They've been part of clouds and stars and planets. They've drifted through space and combined into molecules and become part of living things. And now, for a little while, they're part of you. This is the kind of thought you can hold lightly. You don't need to do anything with it. You can just let it be true in the background, like the sound of rain on a roof. You're made of old materials. The universe has been recycling the same atoms for billions of years, arranging them into different forms, and right now some of those forms include you. Someday, a long time from now, the atoms that make up your body will be part of something else. They'll go back into the soil, into the air, into the water. They'll become part of plants and animals and maybe, eventually, part of other people. The atoms don't mind. They're just atoms. They've been many things before, and they'll be many things again. Let's rest here for a moment. No new ideas, just breathing. The stars are burning. The atoms are drifting. Everything is moving very slowly, on timescales so long that a human life barely registers. And you're here in the middle of it, warm and alive and breathing. That's enough. That's plenty. When you look at a star, you're seeing it shine because of what's happening in its core. But the light you see has actually been on a long journey even before it left the star's surface. Inside a star like the Sun, Photons are constantly being created by fusion, but they don't travel straight from the core to the surface. The interior of a star is so dense that the photons keep bumping into things. They get absorbed and re-emitted over and over, zigzagging their way outward. This process takes a very long time. A photon created in the sun's core might take tens of thousands of years, or even longer, to reach the surface. Some estimates say it could take 200,000 years for a single photon to make its way from the center of the sun to the outer edge. And then, once it reaches the surface, it leaves the sun and travels to Earth in just 8 minutes. So the light warming your face on a sunny day is incredibly old by the time it arrives. It was born deep inside the sun thousands of centuries ago. It wandered through the dense solar interior for ages, and then it made the final sprint across space in almost no time at all. Stars do something else that's rather wonderful. They vibrate. Not in ways you can see or hear with ordinary senses, but astronomers have instruments sensitive enough to detect tiny changes in a star's brightness, and those changes reveal that stars are pulsing. They expand and contract very slightly over and over. These vibrations create waves that travel through the star's interior. Different kinds of waves tell astronomers different things about what's happening inside. It's a field of study called asteroseismology, which is a complicated word that basically means listening to stars. Each star has its own set of frequencies, its own pattern of oscillation. You could almost think of it as the star's voice or its heartbeat. The sun, for instance, has a dominant oscillation with a period of about 5 minutes. Every 5 minutes, it expands and contracts just a little. Of course, you'd never notice this just by looking. The changes are tiny, but they're real and they've been measured. The sun is humming in a sense, very slowly, very quietly, a deep note that no human ear could hear, but that instruments can detect. Other stars have different notes. A star called Alpha Centauri A, which is the closest bright star to our sun, oscillates with a period of about 7 minutes. Bigger stars have longer periods. Smaller stars have shorter ones. If you could somehow speed up the sound and shift it into a range that human ears could hear, each star would have its own tone. The galaxy would be full of music, billions of notes all playing at once, each one produced by the slow breathing of a ball of gas trillions of miles away. You can't actually hear it, of course. Space is a vacuum and sound doesn't travel through vacuum, but the vibrations are there. The stars are trembling, faintly, constantly, all across the sky. There's something peaceful about that idea. The universe isn't silent exactly. It's just playing at frequencies we can't perceive. The stars are oscillating. The galaxies are moving. Everything is in motion, but so slowly and so quietly that it feels like stillness. You can rest in that kind of stillness. It's not the absence of activity. It's activity so vast and so slow that it seems like calm. Let your eyes stay closed if they're closed. Let your breathing be easy. The stars are vibrating, the light is traveling, the atoms are drifting, and you don't need to do anything about any of it. You can just be here, part of it all, without any effort required. When you look at the night sky, the stars seem to twinkle. They flicker and shimmer, especially the ones near the horizon. It's a lovely effect, and it's inspired countless poems and songs. But the stars themselves aren't twinkling. They're shining steadily, the same way they always do. The flickering happens because of Earth's atmosphere. The air above you is moving. There are layers of warm air and cool air, currents and eddies, pockets of different density. When starlight passes through these layers, it gets bent. The technical word is refraction. As the light passes through one pocket of air, it bends one way. Then it passes through another pocket and bends another way. The light is jostled back and forth very quickly, and by the time it reaches your eye, it seems to flicker. That's all twinkling is. It's the atmosphere acting like a lens that keeps shifting and distorting. The star itself is perfectly steady. It's just our view of it that wobbles. Planets don't twinkle as much as stars do. This is because planets are closer to us, so they appear as tiny disks rather than single points of light. The different parts of that disk are affected by the atmosphere in different ways, and those effects tend to cancel out, so planets shine more steadily. If you're ever outside on a clear night and you see a bright light that isn't flickering, it's probably a planet. Jupiter or Venus or Mars, maybe, the steady ones. The twinkling stars and the steady planets. It's a small way to tell them apart if you ever feel like noticing. Here's something else about the atmosphere. It doesn't just make stars twinkle, it also makes them change color. As starlight passes through the moving air, different colors of light get bent by different amounts. Blue light bends more than red light. So sometimes, for a fraction of a second, more blue light reaches your eye and the star looks bluish. Then more red light reaches you and the star looks reddish. The color changes are very fast, faster than you can consciously track, but your eye picks up on them. That's part of why stars seem to sparkle with so many colors when they're twinkling strongly. It's the atmosphere sorting the light and then scrambling it again. If you were above the atmosphere in space, you'd see the stars as steady, unblinking points. No flickering, no color shifts, just calm, constant light. Astronauts have described this. They say the stars in space look very different from the stars on Earth. Clearer, stiller, like lights in a perfectly quiet room. But we're on Earth, under the atmosphere, and so we get the twinkling. And honestly, that's not a bad thing. The flickering is part of what makes the night sky feel alive. It's an accident of where we live, a quirk of having air to breathe, and it happens to be beautiful. Let's slow down again, let the thoughts settle. Stars, light, atmosphere, twinkling, none of it requires anything from you right now. You can let these ideas float past like clouds. Some of them might stick, some of them might drift away. Either way is fine. The night sky has been there for as long as humans have existed. It'll be there tomorrow and the night after and for billions of years to come. You don't need to hold on to any of it. You can just rest. Let's talk about how stars end. Everything ends eventually. Stars are no exception, but the way a star ends depends on how big it is, and the endings are very different from each other. A star like the Sun, a medium-sized star, will end gently. When it runs out of hydrogen in its core, it will start fusing helium. The extra heat will make its outer layers expand, and it will become a red giant, much larger and cooler than it is now. After a while, the outer layers will drift away into space. Not in an explosion, just a slow shedding, like a flower dropping its petals. The layers will form a beautiful glowing cloud called a planetary nebula. Planetary nebulae have nothing to do with planets, despite the name. They're called that because early astronomers thought they looked a little like planets through small telescopes. But really, they're the remains of stars gently exhaled into space. The clouds of gas in a planetary nebula glow because the leftover core of the star is still very hot. It sends out ultraviolet light, which makes the gas shine with colors. Reds and greens and blues, depending on what elements are in the cloud. These nebulae are some of the most beautiful objects in the universe. The Hubble Space Telescope has taken pictures of many of them, and they look like abstract art, like something a painter might dream up. Delicate loops and swirls, layers of color, shapes that seem almost impossible. The Ring Nebula is one. The Helix Nebula is another. There's one called the Cat's Eye Nebula because of its unusual shape. Each one is the remains of a star that lived for billions of years and then, at the end, created something lovely. The core left behind, after the outer layers drift away, is called a white dwarf. It's very small, about the size of the Earth, but it still has most of the star's mass packed into that tiny space. A teaspoon of white dwarf material would weigh tons. White dwarfs are hot at first, but they don't have any fusion happening anymore. They just slowly cool down over time, fading gradually like a coal that's been taken out of a fire. Eventually, over billions and billions of years, a white dwarf will cool down completely and become a black dwarf, a cold, dark remnant that no longer glows at all. But this process takes so long that the universe isn't old enough for any black dwarfs to exist yet. Every white dwarf that has ever formed is still cooling, still faintly visible, still on its way to darkness. This is how the sun will end. In about 5 billion years, it will become a red giant. Then it will shed its outer layers and leave behind a white dwarf. The white dwarf will cool for trillions of years, and eventually it will go dark. It's a quiet ending, no explosion, no violence, just a long, slow fade. The bigger stars end differently. A star much larger than the sun, maybe 8 times as massive or more, will also run out of fuel eventually. But instead of drifting gently away, its core will collapse in on itself. The collapse happens very fast, in less than a second, and when the core can't collapse any further, it bounces back outward. That bounce creates a shockwave. The shockwave tears through the star's outer layers and blasts them into space at incredible speeds. This is a supernova. For a brief time, a supernova can outshine an entire galaxy. Billions of stars, and this one dying star is brighter than all of them combined. It's one of the most violent events in the universe. But even supernovae create beautiful things. The gas and dust thrown off by a supernova form a supernova remnant, another kind of glowing cloud. These remnants spread elements through space, the heavy elements that were forged in the star's core. Gold and silver and iron and calcium, all the building blocks of planets and people, get scattered across the cosmos by these explosions. Without supernovae, there would be no heavy elements anywhere in the universe. The Earth couldn't exist. Life couldn't exist. The violence of a dying star turns out to be necessary for everything that comes after. After a supernova, the core of the star is still there, crushed into something unimaginably dense. If the core isn't too massive, it becomes a neutron star, a ball of neutrons packed together so tightly that a teaspoon of it would weigh billions of tons. If the core is massive enough, it becomes a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. These are extreme objects, exotic and strange, but they're also just the endpoints of a process that started with a cloud of gas and dust billions of years ago. Birth, life, death. Even stars follow that pattern. Let's come back to something calmer now. Let's think about what we can see. On a clear, dark night, far from city lights, you can see about 2,000 stars with your naked eye. Maybe a few more if your eyes are sharp and the sky is very dark. Maybe a few less if there's any haze or moonlight. 2,000 stars. It sounds like a lot, and it is, but it's also a tiny fraction of what's out there. The Milky Way, our home galaxy, contains somewhere between 100 billion and 400 billion stars. Most of them are too far away or too dim to see without a telescope. The 2,000 you can see are just the closest and brightest ones, the ones whose light happens to be strong enough to reach us. And beyond the Milky Way, there are other galaxies, billions of them, each one with billions of stars of its own. You don't need to think about all of them. It's too many. The mind can't really grasp numbers like that, but you can think about the ones you can see. 2,000 stars scattered across the sky, each one a sun with its own story. Some of them have planets, some of them don't. Some of them are young, still settling into their lives. Some of them are old, nearing their ends. 2,000 small lights, each one very far away, each one burning steadily whether anyone is watching or not. The constellations are patterns we see in those lights, groups of stars that seem to form shapes when viewed from Earth. A bear, a scorpion, a hunter. These patterns have names that go back thousands of years. Orion, Ursa Major, Scorpius, Cassiopeia. The stars in a constellation usually aren't actually close to each other in space. They just happen to lie along the same line of sight from our particular vantage point. One star might be 50 light years away, and another in the same constellation might be 500 light years away. They look like neighbors, but they're not. Still, the patterns are useful. Humans have been using them to navigate, to mark the seasons, to tell stories. The constellations are a kind of shared language, a way of talking about the sky that connects us to everyone who has ever looked up. The North Star, Polaris, has been especially important. It sits almost exactly above the Earth's North Pole, so it appears to stay in the same spot while all the other stars wheel around it. If you can find Polaris, you know which way is north. Travelers have used this for centuries. Polaris isn't a particularly bright star. It's not even in the top 50, but it happens to be in the right place, aligned with the Earth's axis, and that makes it special. The alignment is a coincidence, really. The Earth's axis wobbles slowly over time, a cycle that takes about 26,000 years. In a few thousand years, Polaris won't be the North Star anymore. Some other star will take its place for a while. But for now, for our lifetimes and many lifetimes more, Polaris is there, fixed in the north, a steady point in a turning sky. You can let your thoughts drift now. The information doesn't need to stay organized. It can swirl and mix and fade. Stars are balls of gas. Light takes years to travel. Atoms are recycled. Red dwarfs last forever. Planetary nebulae are beautiful. The sky twinkles because of the air. 2,000 stars are visible on a dark night. These are just facts. They're true whether you remember them or not. They're true whether anyone thinks about them or not. The universe keeps going either way. Let's rest here for a moment. A longer pause, no new ideas. Just the darkness and the quiet and the thought that somewhere above you, through the roof or ceiling or clouds, the stars are still there, burning gently, waiting for no one. When the first humans looked up at the night sky, they saw the same stars we see now. The constellations have shifted a little over tens of thousands of years, but most of the bright stars are the same. Sirius was there, the Pleiades were there, Orion was there. Those ancient humans had no idea what they were looking at. They didn't know that stars were balls of gas, or that light took years to travel, or that they themselves were made of atoms forged in stellar cores. They just saw lights in the darkness, and they made up stories to explain them. Some of those stories have survived. The myths of Orion the Hunter, of the seven sisters who became the Pleiades, of the bears and the lions and the serpents that wander the sky. The stories are all wrong, scientifically speaking, but they're also a record of something true. Humans have always wondered about the stars. We know more now than those early humans did. We know what stars are made of, and how far away they are, and how long they live. We've sent telescopes into space that can see farther than anyone ever imagined. We've detected planets around other stars, thousands of them, some of which might even be similar to Earth. But in another sense, we're still doing the same thing those ancient humans did. We're looking up, we're wondering, we're trying to understand our place in something very large. The stars don't care whether we understand them or not. They'll keep burning regardless, but there's something in us that wants to know, that looks up and asks questions, that finds comfort in the vastness instead of fear. Maybe that's what you're doing right now. Not actively asking questions, not actively wondering, but just resting in the presence of something large, letting the size of the universe be a kind of cushion, a reminder that most things are out of your hands, and that's okay. The stars are out of your hands. The movement of light is out of your hands. The cycles of birth and death and rebirth that happen all across the galaxy, none of that needs your input. You can just be here, a small and temporary arrangement of ancient atoms, and let everything else take care of itself. You're doing well, you don't need to do anything more. Just keep breathing, keep resting, let the thoughts come and go as they please. The night is long, and the stars are patient. I want to tell you about a light that's been traveling for a very long time. There's a nebula called the Carina Nebula, a huge cloud of gas and dust, about 7,500 light-years away. It's one of the largest star-forming regions in the galaxy, a place where new stars are being born right now as we speak. 7,500 light-years. That means the light we see from it today left that nebula when the Egyptian pyramids were still thousands of years in the future. Human civilization had barely begun. The light has been traveling ever since, through all of human history, arriving now. And the stars being born there now, the ones that are just starting to shine, we won't see their light for another 7,500 years. Our distant descendants, if there are any, will be the ones to see it. It's hard to think on these timescales. Our lives are so short compared to the journey of light, but there's something peaceful about it too. The light doesn't mind waiting, it just travels, it doesn't get impatient or tired. It crosses the vast dark and arrives when it arrives. There's no hurry out there, everything happens slowly. Even the fast things, like light, feel slow when the distances are large enough. Let yourself feel unhurried now. There's no schedule here, no deadline, nothing you need to accomplish tonight. The light traveling from distant stars will get here whether you're awake or asleep. The universe doesn't need you to watch it. You can close your eyes and let it all continue without you. Here's one more thing about red dwarfs, the small, long-lived stars I mentioned earlier. They're so common that most of the stars in the Milky Way are red dwarfs, but we can't see any of them with our naked eyes because they're too dim. Every single one of the 2,000 stars visible on a dark night is brighter than a red dwarf. This means that the night sky we see is not representative of what's actually out there. The sky we see is dominated by the rare, bright stars. The common stars, the ones that make up the majority, are invisible to us without telescopes. In a way, we're seeing the exceptions. The stars that burn brightest are the ones we notice, even though they're far outnumbered by the quieter, dimmer ones. I find this oddly comforting. The universe is mostly made of things we can't see, not just dark matter and dark energy, the mysterious stuff that astronomers talk about, but also ordinary things like red dwarfs. Quiet stars, burning slowly, invisible to our eyes, but they're nonetheless. There's more going on than we can perceive. The sky we see is just a small slice of the sky that exists. And that's okay, we don't need to see everything. We can just appreciate what we can see and trust that the rest is out there doing its thing. The universe is very large and very old. You're a small part of it. A temporary pattern in the ancient materials, awake for a moment in the long night. That sounds like it could be sad, but I don't think it has to be. You're here, you're aware, you're made of the same stuff as the stars. That's remarkable enough. Let the darkness settle around you. Let your body be heavy. Let your mind slow down. The stars are burning, the light is traveling, the red dwarfs are waiting, and you don't have to do anything but rest. I'll keep talking for a while longer, but you don't need to listen closely. The words can wash over you like water. If you drift off, that's fine. If you stay awake, that's fine too. Either way, the stars are there. There's a star in the constellation Cygnus called Deneb. It's one of the brightest stars in the night sky, part of the summer triangle, an asterism that's easy to find in the northern hemisphere during summer months. Deneb is about 1,400 light-years away. The light you see from it started its journey around the year 600 AD, during what Europeans call the Dark Ages. The Byzantine Empire was at its height. Islam was just emerging in Arabia. The Maya civilization was flourishing in Central America. All of that history has happened while Deneb's light was traveling. And now, tonight, some of it is reaching Earth, landing on rooftops and oceans and forests and fields, landing on you if you're where you can see the sky. Deneb is a supergiant, one of the most luminous stars known. If it were as close to us as the sun, it would be blindingly bright, overwhelming. But it's far away, so it appears as just another point of light, no more impressive than many others. Distance changes everything. Things that would be overwhelming up close become manageable from far away. Problems, fears, worries, they can seem huge when they're right in front of you, but from a distance, they're just small points of light in a very large sky. You're safe here for now. Whatever is worrying you, whatever is weighing on your mind, it can wait until tomorrow. Tonight, you can rest. Tonight, the only thing you need to do is breathe. Let's think about the Milky Way for a moment. On a very dark night, away from city lights, you can see it, a hazy band of light stretching across the sky. It looks like a river of milk, which is where the name comes from. Ancient people didn't know what it was. They made up stories about it, but we know now. The Milky Way is our galaxy. It's a huge collection of stars, gas, and dust, all held together by gravity. When you look at that hazy band, you're looking at the disk of the galaxy Edge-on. You're seeing the combined light of billions of distant stars, too far away to see individually, blending together into a glow. You're inside the Milky Way, about 2/3 of the way out from the center. The Sun is just one star among hundreds of billions in this galaxy, orbiting the galactic center along with all the others. It takes the Sun about 230 million years to complete one orbit around the galaxy. That's called a galactic year. The last time the Sun was in this part of its orbit, dinosaurs were just appearing on Earth. The next time it comes back around, who knows what will be here. The galaxy is moving too, not just spinning, but also traveling through space. It's part of a group of galaxies called the local group, and the whole group is being pulled toward a region of space called the Great Attractor, a concentration of mass that's tugging on everything in this part of the universe. You don't feel any of this motion, of course. The Earth is moving around the Sun is moving around the galaxy, and the galaxy is moving through space, but it all feels perfectly still. You're carried along like a passenger on a ship so large and smooth that you can't sense the movement. Everything is moving, nothing is still, but it feels still, and that's enough. Let's slow down even more now. Long, easy breaths, no need to hold on to anything. The stars are burning, the galaxy is turning, the light is traveling, and you're here resting part of it all. I want to tell you about the quietest places in the universe. Between the stars, there's not much. A few stray atoms of hydrogen, some cosmic dust, the occasional ray of light passing through, but mostly it's empty. The distances between stars are so vast that you could travel for years at the speed of light and not encounter anything at all. This emptiness is hard to imagine. We're used to air, to ground, to things around us all the time. But out there, between the stars, there's almost nothing, just darkness and silence and space. If you were out there, floating in the dark, you would see the stars as steady points of light. No twinkling, because there's no atmosphere, just calm, unblinking light from all directions. The sky would be clearer than any sky you've ever seen from Earth. Every star visible, even the faint ones, because there's nothing in the way. The Milky Way would be a brilliant band across your view, bright and detailed. And it would be silent, perfectly silent. Sound doesn't travel through vacuum. There would be no wind, no hum, no rustle, just your own breathing, if you were somehow able to breathe, and the silent burning of a billion suns. That's a lonely thought maybe, but it's also peaceful. No noise, no demands, just existence, quiet and patient. You don't have to go there to find quiet. You can find it right here, in this room, in this moment, with your eyes closed and your breathing easy. The universe is full of silence. The stars are burning without sound. The light is traveling without noise, and you can rest in that silence even from here. Let your thoughts get softer now. Let them blur at the edges. The stars, the light, the long journeys, the quiet. It all keeps going. It doesn't need you to watch. You can let go and let it continue on its own. I'll keep talking, but the words matter less and less. They're just sounds now, gentle sounds in the darkness. Stars are old, light is patient. You are made of ancient things. The universe is large and quiet and full of slow processes that have been going on for billions of years. And right now, tonight, you can rest. The red dwarfs are burning. They'll burn for trillions of years. No hurry, no rush, just slow, steady light in the darkness. The photons are traveling. Some of them have been traveling for centuries, some for millennia. They don't get tired. They just move through the dark, waiting to land somewhere. The atoms that make up your body have been many things before. There'll be many things again. For now, they're you. That's enough. Let the thoughts fade. Let the words become distant. Just breathing, just resting, just being here in the quiet while the stars keep burning far away. The night is long. The universe is patient. And you can sleep now if you want to. You can let everything go and drift. The stars will be there when you wake up. They always are. They're not going anywhere. Rest now. Let the darkness hold you. The light is traveling. The stars are burning, and you are safe here in the quiet. Sleep. And so the night continues. The stars are still there, above the roof, above the clouds if there are any, above the thin shell of air that wraps around the earth. They've been there this whole time, burning quietly, and they'll keep burning for a long while yet. You don't have to think about them. You can just rest and let them be there, the way you might rest near a fireplace without watching the flames. The warmth is there whether you look at it or not. The light is there whether you notice it or not. Let me tell you something about the color of stars. Stars come in different colors, and the color tells you something about the temperature. This might seem backward at first, because we usually think of red as hot and blue as cold. But for stars, it's the opposite. The coolest stars are red. They burn at temperatures around 3,000 degrees, which sounds hot by human standards, but is cool for a star. Red dwarfs are like this. So are red giants, the aging stars that have swelled up near the end of their lives. As stars get hotter, they shift through orange and yellow. The sun is a yellow star with a surface temperature of about 5,500 degrees. It's somewhere in the middle of the range. The hottest stars are blue. They can have surface temperatures of 20,000 degrees or more. They burn fierce and bright, and they don't last long, cosmically speaking. A few million years, maybe tens of millions, and then they're gone. So when you look at the night sky, if you look carefully, you can see these differences. Some stars have a reddish tint, some are yellowish, some are white or bluish white. The colors are subtle, especially when the stars are twinkling, but they're there. Betelgeuse in Orion's shoulder is noticeably red. Rigel in Orion's foot is bluish-white. They're in the same constellation, but they're very different kinds of stars. Betelgeuse is old and cool and enormous. Rigel is hot and bright and relatively young. The colors are like a code if you know how to read it, but you don't have to read it. You can just look and see the colors and let them be beautiful without understanding them. The sun looks yellow to us, but that's partly because of our atmosphere. The air scatters blue light more than other colors, which is why the sky is blue during the day. By the time sunlight reaches our eyes, some of the blue has been scattered away, and the sun looks more yellow than it really is. From space, the sun looks whiter, more rebalanced, all the colors mixed together. And at sunrise and sunset, when the light has to travel through more atmosphere to reach us, even more blue gets scattered away, and the sun looks orange or red. The atmosphere is painting the light, filtering it, giving us colors that aren't quite real. It's a kind of collaboration between the star and the air. The star provides the light, and the atmosphere shapes it. What we see is neither purely the star nor purely the atmosphere, but something in between, a partnership we're barely aware of. Let that thought settle. The light you see is shaped by many things before it reaches you: the star that made it, the space it traveled through, the air it passed through at the end, and finally, your eyes, which have their own way of perceiving. You're not seeing the universe directly, you're seeing a version of it, filtered and interpreted. And that's okay, that's all anyone ever sees. The filters are part of the experience. Breathe slowly, let your body be heavy. The stars are burning in their colors, red and yellow and blue. The light is traveling, the air is shaping it, and you're here, resting, receiving whatever arrives. Let me tell you about binary stars. Many stars are not alone. They have companions. Two stars, or sometimes more, orbiting around a common center of gravity, bound together by their mutual attraction. Binary stars are very common. Some estimates suggest that more than half of all stars in the galaxy have at least one companion. The Sun is unusual in being alone. Most stars have siblings. In a binary system, the two stars can be very close together or very far apart. Some orbit each other in just a few days. Others take thousands of years to complete one orbit. Some are so close that they share material, with gas flowing from one star to the other. Others are so far apart that they barely seem connected at all. From Earth, many binary stars look like single points of light. We can only tell they're double by looking carefully, by watching how they move, or by splitting their light with special instruments. The universe is full of hidden partnerships. There's a star called Albireo in the constellation Cygnus. Through a small telescope, it resolves into two stars, one golden yellow and one blue. They make a beautiful pair, contrasting colors side by side. Astronomers aren't completely sure whether Albireo is a true binary, with the two stars orbiting each other, or whether they just happen to lie along the same line of sight from Earth. Either way, they look lovely together. The idea of stars having companions is soothing somehow. Even in the vastness of space, things find each other. Gravity reaches across the dark and pulls things together. Stars orbit stars, planets orbit stars, moons orbit planets. Nothing is truly alone out there. Everything is connected to something, held in place by invisible threads of gravity, moving together through the long night. You're connected too, in your own way, to the earth beneath you, to the air around you, to the light that reaches you from distant suns. You're part of a web of connections, even if you can't see most of them. Gravity is holding you gently to the ground. The atoms in your body are linked by chemical bonds. The warmth in the room came from somewhere, traveled somehow, arrived here. Nothing is truly separate. Everything touches everything else, eventually. Let that be a comfort. You're not alone in the dark. You're part of something larger, something connected, something that holds together. Rest now, let the connections hold you. I want to tell you about stellar nurseries. Stars are born in clouds, huge clouds of gas and dust, drifting through the galaxy, cold and dark. These clouds are called nebulae, and they're where new stars come from. A nebula can float peacefully for millions of years, doing nothing in particular, but sometimes something disturbs it. A shockwave from a nearby supernova, maybe, or the gravitational pull of a passing star. And when the cloud is disturbed, parts of it start to collapse. Gravity takes over, the denser regions pull in more material, the clumps grow larger and denser, and slowly, over millions of years, the clumps become stars. This is happening right now in many places across the galaxy. New stars are being born in the Orion Nebula and in the Carina Nebula and in countless other clouds we haven't studied closely yet. The process is slow by human standards, but fast by cosmic standards. A few million years from a collapsing cloud to a shining star. That's not long when you consider that the galaxy is billions of years old. The new stars light up the clouds around them. The ultraviolet radiation makes the gas glow, and the result is some of the most spectacular scenery in the universe. Pillars of gas, glowing caverns, bright young stars surrounded by the remnants of their birth clouds. You've probably seen pictures of these places, even if you didn't know what they were. The pillars of creation in the Eagle Nebula, the swirling colors of the Orion Nebula. These are stellar nurseries, places where new suns are coming into being. And around many of those new stars, planets are forming too. The leftover gas and dust settles into a disk, and within that disk, small grains start sticking together. They grow into pebbles, then boulders, then planetesimals, then planets. It takes a few million years for a planetary system to take shape. And then, if conditions are right, those planets might cool down, and water might collect on their surfaces, and chemistry might start getting complicated, and eventually, maybe, something alive might appear. This is probably how Earth formed about 4.5 billion years ago. Around a new star, in a disk of leftover material, small pieces stuck together until there was a planet. And then, after a long time, there was life. And eventually, there was you. You're the result of a process that started in a cloud of gas, billions of years ago, in a part of the galaxy that no longer looks the way it did then. The cloud is gone, the disk is gone, but the star is still burning, and the planet is still here, and you're resting on its surface, thinking about where it all came from. Let that thought drift. You don't need to hold it. It's just background, just context. The universe has been making stars and planets for a very long time, and it's still doing it now, and it will keep doing it long after tonight is over. Breathe in, breathe out. Let the making continue without you. The universe recycles everything. When a star dies, Whether gently or violently, it gives back the material it was made of. The gas drifts into space, the dust spreads out, and eventually some of that material ends up in a new cloud and the process starts over. Nothing is lost. The atoms that were in one star become part of another star, or part of a planet, or part of a living thing. They change form, but they don't disappear. The iron in your blood might have been part of a star that exploded before the sun was born. The oxygen you're breathing might have come from a different star entirely, one that died in a different part of the galaxy. The calcium in your bones, the carbon in your cells, all of it has a history that stretches back billions of years. You're a temporary arrangement of very old materials. The arrangement is new, but the materials are ancient. And when your time is done, the materials will go back into the cycle. They'll become part of the soil, or the water, or the air. They'll be taken up by plants and animals. They'll move through the world, changing form, becoming new things. Nothing is wasted. Nothing is truly gone. The atoms just keep moving, finding new patterns, new homes. This is comforting in a quiet way. You're part of a flow that's much bigger than any individual life. The flow has been going on for billions of years, and it will keep going for billions more. You're a brief eddy in the current, a momentary shape in the water, and then the water keeps flowing. Let yourself be part of the flow. Let the current carry you. You don't have to struggle. You don't have to hold on. You can just rest and let the universe do what it does. The night is deep now. The thoughts are soft. Let me tell you about the oldest light we can see. It's not from stars. It's even older than that. It's called the cosmic microwave background, and it comes from a time when the universe was only about 400,000 years old. Back then, the universe was very different. It was hot and dense, filled with a glowing plasma. There were no stars yet, no galaxies, no planets, just a sea of particles and energy gradually cooling down. As the universe expanded, it cooled, and eventually it cooled enough for atoms to form. When that happened, the light that had been bouncing around in the plasma was suddenly free to travel. It spread out in all directions, and it's been traveling ever since. That light is still out there. It's been stretched by the expansion of the universe, shifted from visible light to microwave radiation, but it's still there, and we can detect it with special instruments. When astronomers look at the cosmic microwave background, they're seeing the oldest light in the universe. Light that's been traveling for almost 14 billion years. Light from before there were any stars at all. This is as far back as light can take us. Before this time, the universe was opaque. Light couldn't travel freely. The cosmic microwave background is like a wall at the edge of our vision, and we can't see past it with light alone. But we can learn from it. The tiny variations in the microwave background tell us about the early universe, about the seeds that would eventually grow into galaxies and clusters of galaxies. The patterns in that ancient light are still visible, still carrying information from the beginning of everything. You don't need to understand all of this. It's just something that's true, something that happened a very long time ago. The light from the beginning is still here, filling all of space, passing through you right now, too faint and too stretched to see, but present nonetheless. You're bathed in ancient light. The echo of the Big Bang is everywhere, all the time. It's the oldest thing there is, and it's all around you. Rest in that, rest in the ancient light. The universe is about 14 billion years old. That's a number so large that it's almost meaningless. 14 billion years. The sun has been burning for about 4.5 billion years. That's about a third of the age of the universe. The sun is old, but the universe is much older. And the sun will keep burning for another 5 billion years or so. By the time it's done, it will have shone for about 10 billion years total, still less than the current age of the universe. The red dwarfs, the small patient stars, will last much longer. The smallest ones could burn for 10 trillion years. That's almost 1,000 times longer than the universe has existed so far. Try to imagine a universe 1,000 times older than it is now. The galaxies will be different. Many of the stars we see today will be gone. New stars will have formed and died. The sky will look nothing like it looks now. And the red dwarfs will still be there, still burning, still glowing faintly in the darkness. They'll be the last witnesses to a very old cosmos. This is deep time, time so long that human concerns fade into insignificance, time so long that even the stars come and go like seasons. And yet here you are in the middle of it, a brief moment of awareness in the long night, a pattern that formed and will dissolve like everything else. You don't have to be troubled by this. The brevity is part of the beauty. A flower doesn't need to last forever to be worth looking at. A song doesn't need to play eternally to be worth hearing. Your time is short by cosmic standards, but it's your time. It's real, it's happening now. And right now, you can rest. You can let the deep time flow around you and be at peace. Let the thoughts slow down even more. Let them become sparse. Just a few ideas drifting by like clouds. Stars, light, time, rest. The Andromeda Galaxy is the nearest large galaxy to our own. It's about 2.5 million light-years away, which means the light you see from it left there 2.5 million years ago. 2.5 million years ago, early humans were just beginning to use stone tools. The light that left Andromeda then has been traveling ever since, across the void between galaxies, and now it's arriving here. On a very dark night, you can see Andromeda with your naked eye. It looks like a faint, fuzzy smudge, easy to miss if you don't know where to look. But that smudge contains 1 trillion stars, 1 trillion suns gathered together in a spiral pattern, slowly rotating around a central point. Andromeda is moving toward us. In about 4 billion years, it will collide with the Milky Way. The two galaxies will merge, their stars mixing together, their shapes changing. But don't worry, the stars are so far apart, even within a galaxy, that most of them will pass by each other without touching. The collision will be more like 2 swarms of bees passing through each other than 2 solid objects smashing together. Still, the sky will look different after the merger. The familiar constellations will be gone, new patterns will form. The combined galaxy will settle into a new shape, and the night sky will never look the same again. This will happen long after the sun has died, long after the Earth is gone, if it's gone, long after anything we know. But it will happen. The galaxies are already falling toward each other, pulled by gravity, moving at hundreds of kilometers per second. The collision is certain, in the way that distant future events can be certain. You won't be there to see it. No one you know will be there, but something might be. Life might persist in some form somewhere, or maybe it won't. Either way, the galaxies will merge and the universe will continue. This is the scale of things, galaxies colliding over billions of years, stars burning for trillions, light traveling for eons. And you here, tonight, resting. The scale doesn't diminish you, it just puts you in context. You're a small part of something very large, and that's okay. The large thing needs small parts, it's made of them. Breathe, rest, let the scale be what it is. Let me tell you about the space between stars. It's not completely empty. There's a thin scattering of atoms, mostly hydrogen, drifting through the void. There's dust, tiny grains of carbon and silicon and other materials floating in the darkness. There's radiation passing through on its way from somewhere to somewhere else. But compared to anything we're used to, it's empty. Fantastically, incredibly empty. If you took a cubic centimeter of air at sea level, it would contain about 25 quintillion molecules. If you took a cubic centimeter of interstellar space, it might contain 1 atom, maybe less. The emptiness is hard to imagine. We're used to being surrounded by stuff. Air, walls, ground, but out there between the stars, there's almost nothing, just space and time and the slow passage of light. And yet things do happen in that emptiness. The sparse atoms drift together under gravity, very slowly, and eventually form clouds. The clouds collapse and form stars. The stars live and die and scatter their materials, and the cycle continues even in the near vacuum. The emptiness isn't sterile. It's fertile in its own slow way. Given enough time, even almost nothing can become something. This is true for you too, in a different sense. The quiet moments, the empty moments, the times when nothing seems to be happening, those moments are part of the process. Rest is part of the cycle. Stillness is part of the motion. You don't have to be doing something all the time. You can be like the interstellar medium, quiet and sparse, waiting for the next thing to form. Rest in the emptiness, let it be spacious and calm. The stars are very far apart. Even in the densest parts of the galaxy, the stars are separated by light years. They shine alone in the dark, each one surrounded by vast stretches of nothing. And yet from here, they look close together. The constellations seem compact, the patterns seem tight. It's an illusion of distance. The sky looks crowded because we're seeing it from so far away. If you could travel to one of those stars, you'd find it surrounded by its own vast emptiness. The nearest neighboring star would still be light years away. The darkness would stretch in all directions. And if you looked back toward the sun, it would be just another point of light in the sky, small and faint, no different from any other star, unremarkable. That's a strange thought. The sun is the center of our world. It gives us light and warmth and life. But from a few light years away, it's nothing special, just another star in a galaxy full of them. This doesn't make the sun less important. It just means that importance is relative. What matters to us doesn't have to matter to the universe. The universe doesn't have preferences. It just exists, and we find our own meaning within it. Your life matters to you, even if it doesn't matter to the cosmos at large. The things you care about are real, even if they're small. The scale of the universe doesn't erase your experience. It just puts it in a different context. Rest in that context. Let your concerns be small. Let the universe be large. Both things can be true at once. The night is very deep now. The words are very soft. Let me tell you one more thing about stars, and then we'll let the words fade. Stars don't burn the way fires burn. A fire needs oxygen. A fire is a chemical reaction, atoms rearranging themselves, releasing energy as they go. Stars are different. Stars are nuclear. They're not rearranging atoms, they're changing atoms into other atoms. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen. This is a much more powerful process than ordinary burning. The energy released by nuclear fusion is millions of times greater than the energy released by chemical reactions. That's why stars can shine so brightly for so long. And yet the process is gentle in a way. It happens in the core of the star, deep inside, where the pressure is enormous. The outer layers don't know about it directly. They just feel the warmth radiating outward, keeping them puffed up against gravity. The fusion happens quietly, steadily, without any drama. Atoms combining, releasing energy, one after another, trillions upon trillions of times per second, and the star just glows. It's not trying to be impressive. It's just doing what stars do. There's a kind of peace in that. The star isn't striving, it isn't worried. It's just being what it is, following the laws of physics, existing in the only way it can exist. You can be like that too sometimes, not striving, not worrying, just being what you are, resting in the only way you can rest. The stars are being themselves right now, burning gently, glowing quietly, existing without effort. And you can do the same. You can just be here without effort, resting in the dark. The words are almost done now. The stars are still burning, the light is still traveling, the atoms are still drifting. And you can let go of all of it. You can let the universe take care of itself. You can close your eyes, if they're not already closed, and let the darkness be soft. The night is long. The stars are patient. And you are safe here in the quiet. Let the thoughts fade. Let the words dissolve. Let sleep come if it wants to. The red dwarfs are burning. They'll burn for trillions of years. The light from distant stars is traveling. It's been traveling for centuries. The atoms in your body are ancient. They've been many things before. You don't need to remember any of this. You don't need to do anything at all. Just rest. The universe is large and old and quiet. The stars are there above you, whether you think about them or not. The night continues, and you can sleep now. You can let everything go. Sleep. The stars are burning. The light is traveling, and you are resting, part of it all, held by the dark. Let go. Sleep. The night continues, soft and long. Somewhere above you, light from a star that died 1,000 years ago is just now reaching Earth. Somewhere else, a new star is being born in a cloud of gas, slowly brightening, starting its long life. You don't have to think about any of it. The universe is doing its thing, and you can rest. If you're still awake, that's okay too. There's no pressure, no deadline. Just quiet and the thought of stars and the long, slow turning of everything. The Milky Way is wheeling overhead, even if you can't see it. The Earth is spinning, carrying you around. The Sun is orbiting the galaxy. The galaxy is moving through space. All of it silent, all of it slow, all of it happening whether you notice or not. You can just be here, breathing, resting, part of the motion without having to move. The stars are far away. The light takes years to arrive, and you have all night. There's no rush. Let the darkness hold you. Let the quiet settle. Let sleep come when it comes, like light arriving from a distant star. Patient, unhurried, inevitable. Rest now. The stars are there. The night is deep, and you are safe. Sleep. The light keeps traveling. The stars keep burning. The universe keeps existing, vast and old and quiet. And somewhere in a small room, on a small planet, orbiting an ordinary star, you are resting. Part of it all. Let go. Sleep. The night is long. The stars are patient. And you are home. Sleep.